Any questions from homework? Aaron?
3.4, number 7 and 10.
Oh, I forgot to share. Hold on. Okay. 7, 10. 3.4. Let's see. So 3.4 is try to find this. All right. Okay, if this feels like confusing, I mean, I would say like skip less steps and try to write down as many details as possible. Okay, so the key here is it's a product. So product rule definitely work. That will be step 1. After that, let's just take the derivative. Number 1, 13 goes to 12 times the derivative of the inside, which is 6. Similarly, 8 goes to 7 times the derivative of the inside. In our case, this is going to be 7x to the 6 plus 4x to the cube. Okay, so together, let's clean things up. That will be the final answer. For our class, don't FOIL further down because this already looks simple enough. Okay, don't try to simplify more. Sounds good? Okay, that will be number 7. Now number 10. The derivative of all right, so they ask you to find g prime y. If they write things in this way, this is basically the same as saying dgy with respect to y. So you don't have to times y prime because we don't have a function of x here. It's a function of y. Okay, so that's the first thing. After that, just pretend it's y, x, and then this is nothing but a quotient rule. Okay. The derivative of the top. Which is just 19. Okay, of the inside. Keep the bottom. Minus. Keep the top. Derivative of the bottom. Times the derivative of the inside. Which is 27 y to the 26 plus 5. Okay, the rest is just clean things up. That'll be how we finish the whole thing in terms of quotient rule. Sounds good. It's a lot of stuff, but if you look into it, it's just copying a lot of stuff. Okay. The key is still the quotient rule and then some power. Now, like I said before, you have a lot of dividing times and power. Another possible approach is just take the log. Since we're doing log differentiation, right? Let's see what's going to happen. If we just take the log, it's going to be ln 6 46. Okay. Now if you take the log, this one become ln 19y minus 8 6 minus ln 127 y 46. Number 2, the 6 can go here, the 46 can go here. Still okay? Now let's finish. Six. Times the y. Okay, this will be the answer if we do log differentiation. Sounds good. What do you save? Well, number 1, you didn't do the quotient rule. You didn't do that at all. Second, you didn't have to do the big power of 46 and 6. Why? Because when you take the log, the 46 and 6 just become a constant times. You do nothing about it. Still okay? That's the beauty of log differentiation. For this case, I would say log is still better than just doing things in a regular way using quotient rule. But if you have one more factor, log is definitely better. It's shorter. All right, that's number 10. Adam?
Yeah, could you do problem 10 In 3.3.
3.3, 10. Limit this equals that. Okay. For problem like this, from now on, just keep in mind the only thing we need is this fact is 1. Okay? With that in mind, what we need to do is to make sure the thing here and here are the same. So when you do it, it becomes 1. Okay? So you manually add 4t there to make this happen. You manually add an 8t here to make this happen. But then you cancel the 4t you just added. You cancel the 8t you just added to make sure you stay the same. 1, 1, which is 1/2. Sounds good? All right. Canyon?
Would you be able to go over 3.3 number 9, please?
All right. Let's see. Find the equation of the line to this at the point this. The equation of tangent line be written in the form this, but I missed that. Okay. The tangent line of at. Moreover, when you finish, try to use this form, the slope-intercept form. Okay, that's not a big deal. You first write down a line and then change it to it. Okay, so now this is what you have. You want to find a point for a line, which you already have. Check. You just need a slope, and you know it's going to be f prime at pi over 4. With that in mind, let's just do the f prime x. That's it. Then you just need to plug in pi over 4. Okay. What is secant square pi over 4? What is cosine pi over 4? Square root 2 over 2. Okay. With that in mind, this is 5 times 1 over 1/2, which is 10. So slope is 10. That will be the tangent line. And finally, this will be your M. The thing with a negative sign is going to be your B. Cool. Other questions? All right. 3.6, we were talking about log. First one is the derivative of log is going to be this, and the derivative of log base a for anything is going to be 1 over x ln a. From here, you can see we are going to use this one a lot. This is less frequently, but we need to know it. Good. Second, we were talking about the advantage of log because log has nice properties. Why are these properties nice? Well, because basically they change the product to sum. They change quotient to subtraction. They change the power to product. Okay? Then if you do the derivative of a product, you can do the log and take a detour. Instead, you do the derivative of a sum, which is super easy. When you do the derivative of a quotient, which you apply a quotient rule, which is super long, when you do that with a log, you actually use subtraction. Again, it's super easy. When you do the derivative of a power, sometimes it's impossible. Okay, but then you can change it to a product. It's not pretty, but at least it's possible. That's basically what we're trying to do. Okay. So I think we have some example last time. You basically know what it is. It's just something like a lot of multiplications. Okay, we say this is a disaster if you do the quotient rule and then a lot of product rules. Okay, it's gonna be very long, very confusing. But if you just apply ln, okay, what you realize is this one is going to be ln something plus ln something plus ln something minus ln something minus ln something. Okay, there's no more product. There's no more power anymore. So the whole thing becomes super easy. Plus, on the left, it's not too bad either, because the left look like this. So when you finish, you just need to times the y on the other side. And how to do the other side? You just use chain rule. That's roughly the idea of log differentiation. Sounds good? All right. Now we want to push a little bit further. This time, we want to use the power and try to see how log can help us to solve something which is impossible. For example, if a function look like this, okay, what's the derivative? Well, number one, this looks nice. Do we have a formula? It depends, right? If it's x to the cube, which means this is a variable and this is a constant, I can do the power rule. I can have 3x to the square. According to that, what I have here should be x times x, x minus 1. Something similar to that. Second, if there is a constant here, but there is an x here, I should do the exponential rule. So what I end up with should be x times ln x. Still okay? Can you see that this case belongs to neither? Because you don't have a constant. It makes sense for you to say it's similar to this. It makes sense for you to say it's similar to this, but it's just similar. It's not either of the cases. So you cannot simply just apply a formula and do it because there is no constant. Sounds good? Then how are we supposed to do it? Well, again, you have a power. You hate the power. Let's do ln. Good news is this power is down. Now you have a product. Okay, this is not doable. This is doable because if you take the derivative of this, it's nothing but a product rule. I can do it. This is impossible. Sounds good? All right. After you apply ln, what do you have? You basically have this. You want to find y prime. That's exactly implicit differentiation, right? Just take the derivative on both sides. Derivative of this product rule. Ln x plus, which is 1. So finally, y prime equals ln x plus 1 times y, and the y is given by sounds good. And from here, you can see this one is more like an exponential, because if it's exponential, we're going to do things in this way, right? Roughly, it's very similar to what we got here. But from here, you can also see it's not exactly the formula. You have a plus 1 there. All right. Make sense here? Okay, so next time if you see some power, if you find it impossible, you can always try this. Actually, you can even try this for all the stuff we had before. For example, what's the derivative of x cubed? Of course, it's 3x squared, right? By the formula. But this time you don't have to do it. What you need to do is just like, oh, y equals x cubed. Well, ln y equals ln x cubed. Still okay? Which is 3 ln x 1 over y times y prime. That equals, so y prime equals 3 times 1 over x times y. Y is x cubed, which is 3 times x squared. Can you see that? So actually with the log rule and the implicit differentiation, you don't even have to remember the power rule anymore. You don't need it. You know, just do this. What about exponential? What's the derivative of this? Of course, we know it's this, right? But forget about it. Let y equals e to the x, okay, ln y, just equals ln e to the x, which is just x. Take the derivative. We can have this also. Okay, so a lot of things we had before, now we don't have to memorize anything. Still okay? Some other examples. What's the derivative? So I need to put this here. Oh, that's here. Okay. What's the derivative of tangent? Well, secant square. Remember? Okay. How did we do that? We basically changed the tangent x to be sin x and cosine x. And then we apply the quotient rule. Sounds good? Now you say, well, you have log differentiation. You technically don't need the quotient rule anymore. You just need to take ln y that's good. Ln sin x minus ln cosine x. Take the derivative 1 over sin x by the chain rule times cosine x minus 1 over cosine x by the chain rule times negative sin x. Sounds good? Pretty easy. And then let's finish. It's y prime equals y, which is tangent, times whatever you got here. What is cosine over sine? That's cotangent. What is sine over cosine? That is tangent. Still okay? What is tangent times cotangent? 1. What is tangent times tangent? Tangent square. What is 1 plus tangent square? That is secant square. Sounds good. It's beautiful. With log, you can forget almost everything you had before. Okay, except for some very, very basics like sine and cosine, there's no shortcut. Okay, but all the other 4 tricks, log can handle it. Exponential, log can handle it. Power, log can handle it. So log basically can handle everything. Of course, you need log, implicit differentiation, and the chain rule. Okay. So from now on, there's no uniform way for you to ask to do the problem. If you want to do log, feel free. If you don't want to do log, you want to do product or quotient, feel free. Okay. You can pick whichever one you prefer. And I will take either, whichever way, as long as you have the right answer. You follow the same, you follow the correct procedure, I will give you the point. So it's your call, which way you want to take. Sounds good? Cool. With all that in mind, let's just try some examples all together. Sin x to the power of cosine x, that's number 1. Number 2, y to the x equals x to the y, which is something we don't even know how to draw, but we want to find y prime. Number 3, okay. Let's do all these in class, one after another. And once you're okay with the last one, because this is like the ultimate challenge, this is like a boss of this level. Once you're okay with this, not only you're okay with 3.6, you're okay with everything from 3.1 to 36.6, because this one uses everything there. All right, let's try them. By the way, I just received an email from the careers office, and you guys will have a career fair tomorrow from 10 o'clock to 2. If you're looking for jobs, no matter part-time, full-time, intern, whatever, you should really attend this event. Okay, it introduces you to like 50 different employers locally, so you can find some part-time interns later. Okay, so if you think you need to go to the career fair and you will miss our class, just let me know. Okay, the career fair is way more important than just one lecture. Okay, so if you are thinking about looking for jobs, you better start now to cover, for example, your expenses for next semester. I posted the link in the chat box, so just click there and you will find it. And if you don't have a Handshake account, you better register one if you are looking for internships. Any question regarding the first one? Nick?
Were you in like the second or third step? How do you get the plus cosine of x?
Here? Hold on. Yeah.
The other one.
How did they get cosine x? Oh, you mean the other one? Okay, I see. This one?
Yeah, that one.
Okay, that one come from this. So it's like a product rule, right? You do the derivative of the cosine, keep the ln, and then you keep the cosine to the ln. Okay, everything else come from the derivative of ln. Whoa, what did I do? Okay. Yep. Everything else here come from the derivative of ln sine. So you first take 1 over x, which give you 1 over sine x. Then you time the derivative of sine x, which give you cosine x. Okay, any questions regarding the second one? Cool. From here, you can see with implicit differentiation, your function or equation can look like anything. So there is really no ultimate rule of how to do a certain problem. It's just like a certain tool does a certain thing. Whenever you feel like there is a need for doing the log, no matter it's on the left or the right, just go ahead and do it. Okay. Usually that thing will make your life easier, even it doesn't solve it directly. Okay, so if you're okay with second one, let's finish the third. Okay, if you have questions, raise it. If you feel like you're, how to say, you can do this on your own with a very low chance of making mistakes, you're all set for everything in chapter 3 so far. Okay, the only thing left is 3.9 related rates. But other than that, you are super good with differentiation and all the rules now, if you can finish this one with no mistake. All right, that will be all for today. If you still have questions today, I will answer it.